My name is David Ehrlich. I am a senior solutions architect with Sisense. We'll be talking about data groups, what they are, why we use them. Then we'll go into a demo, talk about the use cases for it. And then finally, we'll have Q&A. What are data groups? Data groups are entities that have similar resource utilization needs. They combine the entities are ElastiCubes, and they group ElastiCubes where they have similar resource needs. In addition, data groups associate ElastiCubes with the underlying hardware resources and specify limits on those hardware resources. Data groups contain one or more ElastiCubes. Why do we use data groups? Data groups allow ElastiCubes to be separated from the underlying resources that they use. This provides a layer of abstraction. It also allows resource groups to created for ElastiCubes that have similar resource needs. If you have ElastiCubes that require a lot of resources and some that require fewer resources, you can group them together in separate data groups with separate resource specifications. How do we use data groups? Data groups allow ElastiCubes to be abstracted from the underlying hardware resources needed to run the ElastiCube. This provides greater flexibility and mobility if we need to move data groups or the instance among different installations. Data groups serve as a bridge between ElastiCubes and the hardware resources needed to run the ElastiCube. Let's give a demo of data groups. Okay, so data groups can be accessed through the admin tab. And we can see if we go into server and hardware, we'll see data groups under there, right there, okay? Then if we click on the pencil button, we can edit a data group. We'll see that every data group, every instance has a default data group, okay? So here's where we edit and configure a data group. First, we'll give a data group a name. The default data group is named default, but it could be renamed to test or something like that. We then specify what node will be in the data group. So for builds, you specify the nodes that have the roles of build will be shown here. This is only a single instance, so only one instance is showing. But if there were multiple nodes that had the build role, they would show here. The same goes for query nodes. In a multi-node setting, we'd have at least 2 query nodes, and they would show here. And if you only wanted ElastiCubes that belong to one data group in one query node, you could specify it and not specify the other. This could be useful if you're providing larger resources to certain nodes. Then you specify which ElastiCubes belong to the data group. By default, all ElastiCubes are put into the default node, a default data group. But you could unselect an ElastiCube from the data group, and then it could be reassigned to another data group. We'll just leave all the ElastiCubes in the default data group. How many instances could be in a data group? The instance corresponds to the number of Kubernetes pods or services that will be responsible for processing queries related to the ElastiCube. By default, it's 1. In a multi-node setting, you could increase it to 2 or even higher. There's also an option when the data group is idle, hasn't been used for a certain period of time, and ElastiCubes are used when queries are accessed through dashboards that utilize that ElastiCube. you could toggle this on, and there's an idle minutes parameter. And if a data group, sorry, if an ElastiCube is not used for 30 minutes, the pod will be terminated, will be shut down, and that'll free up resources. So if you have a use case where ElastiCubes are being used, maybe dashboards are being used in the morning, and then they're not being used for the rest of the day, that might be a situation where you might want to set the data group to stop when idle and then set the idle to a certain number of minutes. The ElastiCube recycler. The ElastiCube recycler is used to recycle queries in order to speed up processing. That should, by default, that is on, and that should be left on. There are certain cases where if there's complex data security, the recycler will be caching queries, but you won't get advantage because every query is different due to complex data security rules. And in that case, you won't want to use the recycler. You'll toggle it off. But by default, it should be toggled on. These next two settings have the default and should only be changed for debugging purposes. So connector running mode specifies whether the connectors will be processed internally or have their own system connector. By default, it is internal. It should only be changed to system if, with the advice of Sisense support used for debugging. Custom code mode is the same, specifies whether the existing custom code pod will be used to process custom code or whether a new internal custom code pod will be spun up. Index size. If you have index fields that are long string fields greater than 300 bytes, you might want to consider using a long index. The default index is, I believe, 32-bit. If you need longer than that, you would go with long index. Obviously, it uses more resources, so should only be used if needed. Simultaneous query execution. So for the ElastiCube in this data group, how many simultaneous queries will be executed? And the default is 8. That should be left as is unless working with Sisense and needs to be adjusted. Query timeout. How long will query for the ElastiCube run before timing it? The default is 300 seconds or 5 minutes. That can be adjusted down if you know that queries that run, let's say, longer than 100 seconds are going to fail. You can reduce that query timeout so the queries aren't having to wait around long enough when you know they're going to fail if they haven't completed after a certain amount of time. Percent concurrent cores per queries. Queries can be divided up and are divided up among multiple cores to speed up processing so the queries are processed in parallel. So you can set this to what's the percent of concurrent cores, how many cores will be used in parallel to process a single query. By default, it's 50. So if you are on a node that has 8 cores and you have 50% concurrent query, that means that maximum of 4 cores will be used to process a single query. This value should be set so that it ultimately results in no more than 8 cores processing a single query. So if you have 16 core, 50 is good. That'll result in 8. If you have 32 core, it should be set to 25. If you have 64 core, it should be set to 12.5. The following settings relate to resources that are allocated for the build node and the query node. Reserve core is what are the minimum number of cores that will be allocated when a build is created for the ElastiCube. And then what are the maximum number of cores that can be used? And the same thing for RAM. Minimum number of RAM expressed in megabytes and maximum number of RAM. -1 denotes no minimum or maximum. So in this case, the default is for a build, there's no minimum number of cores needed to create a build pod. There's no maximum number of cores either. However, for the RAM, a build pod will be created with 512 megabytes and can use no more than 8 gigs. This can be adjusted as necessary. For the query nodes, all the values are set to -1. This is because we don't want to limit the processing of the queries which get executed from the dashboard, and users are waiting for these queries to execute, and we want to devote as many resources as we need. That's why the defaults for these are all set to -1. So you'll see the build nodes have the memory cap. So if you're running a single node and you have build and query roles on the same node, this will give preference to the query. So if the build reached their maximum memory limit, they will be terminated. We don't have that for the query. There are certain cases where you want to set a maximum amount of RAM, maximum amount of cores for the query. User labels can be set. This is useful when this is useful for auto scaling. You can set a label, and then when different roles, when the nodes are auto scaled, nodes are added, they'll have the same label, and this is useful for auto scaling. The following settings are applied per build. Interim build on local storage. This specifies that the ElastiCube will be built on the local storage. If this is done, you need to make sure that there is sufficient disk space on the local storage. You can toggle that on. For AWS environments, you can specify that the ElastiCubes, once they're built, the data will be stored on S3. S3 is not quite as fast as local storage, but it is faster than shared storage. If you turn this on, it's required that the build be on local storage, and that setting is also automatically toggled on. Query cube from local storage specifies that after the build, rather than the ElastiCube data being put on shared storage, it will be put on local storage. This can be done if the response times from shared storage are not fast enough. They can be faster from local storage, but again, this requires sufficient disk space be allocated to each of the local storage, each of the nodes. Okay, if you turn this on, again, this requires build on local. We'll toggle it all off. And those are the settings that can be configured. Okay. We'll go back to our presentation. Okay, so these are screenshots just for your, if you want to go back and consult this later, you can look at it and you can see the screenshot. Here are all the settings. They are laid out. And here are brief descriptions of all the functions. So we can associate one or more nodes for the build. We have one or more nodes for the queries. We can select the ElastiCubes that would be part of the data groups. The number of instances determine how many query pods will be created for each cube. We said one instance should be used for single node, 2 instances for multi-node. 2 instances will provide redundancy and potentially faster Jackal processing, that's processing the queries. The downside is that you're going to use more CPU and RAM. The ElastiCube recycler will store queries in memory for faster processing. ElastiCube resource settings. For build and query roles, the reserved core and RAM, and maximum core and RAM can be set. Reserve denotes the minimum that are needed to schedule, and maximum denotes the maximum. If you don't have the minimum required on the node, Kubernetes will look to schedule that on another node. If there's not another node that does not have the available resources, the pod will not be able to schedule. For builds, the max RAM is designed to prevent a runaway build from consuming all the resources. As we said, -1 denotes no min or maximum limit. And then they can be set separately for each build node. We talked about advanced settings, the ElastiCube recycler, the active running mode, custom mode, index size, short and long. It defaults to short, simultaneous query executions, the query timeout, percent concurrent core per query, and user label. Storage settings we talked about, interim build on local storage, storing the data on Elastic on S3, and then query cube from local storage.